Welcome to Constellations, the podcast from Kratos, where industry leaders share their thoughts and experience on the future of space business, policy, and opportunity. If you like Constellations, please support us by giving a rating and review on iTunes. And don't forget to share this podcast online to help our community grow.
Welcome to Constellations, the podcast from Kratos. My name is John Gilroy, and I'll be your moderator. Our guest today is Gino Bucciol, co-founder and chief development officer at a company named Officina Stellare, or Officina Stellare as well. Let me give you a few hashtags to describe today's episode. Hashtag telescopes, hashtag ruggedized optical systems, and hashtag laser communications. Sounds like a great interview, yeah. Well, we're about to get into the heart of it with our guest, Gino Bucciol, talking us today from Italy. Gino is the co-founder and chief development officer at Officina Stellare, a company based in Italy and active in the design and production of telescopes, optomechanical and aerospace instrumentation for ground and space-based applications. Gino will discuss the new space economy, which is how Officina Stellare refers to those opportunities that will arise in the future thanks to a growing accessibility to and democratization of the space industry. Some of the applications that will drive the new space economy are Earth observation, or EO, space situational awareness, SSA, laser communications, and ruggedized optical systems. SSA and EO both use ground telescopes and space-based optical payloads to monitor awareness. In today's discussion, we will learn the advantages of each. Finally, Gino will share with us the importance of ruggedized optical systems in a congested and contested space environment. Well, Gino, sei pronto? Are you ready?
Sono pronto.
Oh, good. That's two words I know in Italian. That's not a good way to start the conversation, I guess. Well, let's start off with what we call in the United States the elevator pitch, In 30 seconds, can you give us a little nutshell or tell our listeners what Officina Stellare does?
Thank you, John, for having us. John, I will do my best, then please stop me if something is not clear. Officina Stellare is an Italian-based company with headquarters not far from Venice. It is a vertically integrated design and manufacturing firm focused on all the processes involved in the development of an optical system. Optical systems that people normally call telescopes for both ground and space-based application. This is our strength. What makes us interesting on the international panorama is that the full value chain is kept in-house. It means that we can easily go from the mere idea to the delivery and the commissioning of a product. So we can support the customer in a fast, smart, and cost-effective way.
When I think of Venice, I think of Marco Polo and the end of the Silk Road. And so 500 years ago, Venice really was the center of the world for communication, wasn't
Correct.
It? Right. And you're doing it again, only you're going up instead of east and west, huh?
Yes.
Yeah, Marco Polo. Well, we never thought we'd talk about that in one of these podcasts. So, Gino, your telescopes are ground-based, space-based, or both?
Our telescopes are designed for both ground and space applications. When used on Earth, they typically serve research and astronomy activities or defense applications like weapon tracking. Talking about space, our telescopes are used for debris tracking, satellite collision avoidance, or laser communication.
So when do you use one? There's a strength and advantage of each one. When do you use ground-based? When do you use space-based?
On the basis of the customer request. Some application needs for space-based telescopes, some other application needs for in-orbit application. As example, in orbit, we perform with our telescopes Earth observation or, again, laser communication from the other side of the comlink.
When I went to your website and did some research on your company, there's three words you kind of reinforce, and the words are new space economy. So how do you describe that for our audience?
You're right, John. Space is quickly becoming a place where it is possible to develop commercial activities. The easier access to the orbit, thanks to the launch reduction costs and the availability of space-compliant technologies, has made possible also for private companies to do business up there. This is the famous space democratization. From here, the decision to focus on all the applications that have a telescope in their core. I'm referring to this field of application mainly, Earth observation, space situational awareness, and laser communication.
Good. I'm just going to focus on one aspect of what you folks do. Telescopes, radar, and RF sensors have all been used in space situational awareness. So how do they differ in their approach, each one of those?
Space situational awareness need for both kind of sensor. The information obtained from the different sensor you mentioned must be combined together to get the result. The result is the full awareness of the real-time position and the trajectory of the tracked objects. Telescopes are perfect to provide information on the angular position thanks to their extremely high resolution. Radars, instead, are perfect to obtain precise measurement of the object distance. Then the combo of the two sets of information give you a complete awareness of where the tracked object is in space.
So it's not a matter
of where it will be.
Yeah. So one alone may not be enough. However, two or three combined can give you information about where an object will be, huh?
Right. Correct.
Good. I want to focus again on space situational awareness. These telescopes are ground-based, aren't they, or space-based?
Space situational awareness, SSA, till now has been performed mainly from ground with a dedicated tracking telescope. The recent evolution of the space situational awareness techniques is now also including space-based assets. It is a really new field of application in which we are starting to be involved. EO telescopes, Earth observation telescope, are very different from the laser one, for the laser com ones. The first ones, the Earth observation telescope, are designed to produce an high resolution picture, and these are required for larger diameters and special imaging sensor. The second one, lasercom, are designed to send and receive modulated laser beams with a totally different set of specifications and the related hardware.
Good. You mentioned Earth observation earlier, EO, and I tell you what, all kinds of applications are growing. I mean, you read magazines, you see what's going on, you're getting bombarded with all kinds of applications. Can you give our listeners, maybe give us a clue on how optical systems are being used for satellite Earth observation?
Sure. Space telescopes are placed in a perfect position for observing the Earth, and we can use them to get a precise image of a specific area in order to monitor what is happening in that area. It could be useful for natural disaster prevention, intelligent agriculture, border protection, sea and river monitoring, etc. There are many applications that can use the set of information that can obtained from a high-resolution picture of the ground surface.
Try and expand on a comment you made earlier about laser communications. I think Officina Stellare, it goes way beyond, laser communication going way beyond telescopes. Is that true?
Yes. An optical ground station, this is the name, the right name for a ground-based telescope used for lasercom application. Optical ground station includes a telescope, an extremely precise tracking mount to keep the satellite aligned with the line of sight of the telescope, and a set of light modulation devices. All these parts are developed in-house by Officina Stellare. The promise of the future laser communication infrastructure is its capability to transfer data with a way faster throughput, a worldwide coverage, lower power consumption, and, talking about quantum com, a totally secure transmission.
Gino, thousands of people from all over the world have listened to this podcast. Go to Google and type in Constellations Podcast to get to our show notes page. Here, you can get transcripts for all 97 interviews. Also, you can sign up for free email notifications for future podcasts. When I went to your website and I did some research on your company, it looks like Officina Stellare also produces optical payloads. I mean, are they different from telescopes, and how are they used?
You are right, John. Sometimes people are confusing the two items. With payloads, we normally refer to the combo of an optical system and the imaging device, plus all the other electronic and hardware it is related with, like the focuser, for example.
Maybe you can define that a little better for me. So an optical payload is just a system that a satellite would contain? Is that what it is?
Yes, a satellite dedicated to the Earth observation application is a satellite with inside an optical payload. The optical payload is a combination of two main parts, the telescope, then the optical section, and the imaging device, the camera.
Ah, okay, I got it. When we look at the evolution of technology in the last 4 or 5 years, nothing really evolves without some serious challenges. So what challenges do you face in the world of optical technologies?
Many, John. The optical world is a challenging one. For example, space applications are asking for larger telescope diameter, lower weight, and smaller overall allocated volume for the payloads, because the cost of the launch is directly related with the size and the weight of what you are sending up there. Then the people are looking for more compact and lighter solution to perform their research. Then new designs, new materials, and new technology shall be developed in the near future to cope with this request. In addition, the continuous improvement of the imaging sensor demands for a better optical performance to increase the resolution and the quality of the pictures taken. It is definitely not an easy job for us.
In other words, Gino, you want to buy a car that's as fast as a Maserati, but costs what a Volkswagen costs. Not just produce that, right?
That's new space economy.
And that's a challenge, I'd say.
Right.
So there's a concept called a space factory. Are you folks trying to look to create some kind of a space factory?
A space factory, and our one is one of the very first in the world, is a place where all the design, manufacturing, integration, and verification phases of a space product, an optical space payload in our case, can be performed with small needs for external support. As said in Incipit, it is a vertically integrated manufacturing firm with raw materials in input, glass and metals in our case, and finished products, the optical payload, at the output. Good. Having in the same building the engineering team, the optical and mechanical manufacturing, the clean rooms for the integration, and all the really special assets required for the test of the space product, like the launch and space simulators, is a uniqueness of Officina Stellare. New space economy is asking for smart processes, faster developing time, cost saving, and risk mitigation. We can deliver all of that.
So I need an Italian lesson. So how do you say the word lawyer in Italian? How do you say that in Italian?
Lawyer is avvocato, probably.
Avvocato.
Yes.
Well, one of our recent guests, Randy Siegel of Hogan Hovels, is an avvocata and an expert on space law. And she was explaining how merging space law was attempting to address space debris. Now, is this something in your strike zone? Is this an application where telescopes can help track debris?
Definitely yes, John. Space debris are an issue that is having a fast-growing attention by multiple players, like satellite operators, military people, and for sure also space law experts. The number of satellites, especially in the low orbit, is increasing as a consequence of the space democratization. In fact, the possibility of a collision is now not remote. Ground and space-based space situational telescopes are an extremely important tool to mitigate the risk, thanks to the patrolling activity they can perform. Good.
So it might be a tool that they can use to control space debris. When I read your press releases, I hear about your company, I talk to people about Officina Stellare, it looks like that you design and develop optical systems for the defense industry. So give me an idea here. What's the typical application the defense sector looks for when they commission optomechanical systems from your company?
For the defense market, we developed an important know-how to serve customers dealing with the weapon range tracking application. These telescopes face large thermal and mechanical stresses because the harsh environment and the challenging operating condition in which they are normally used, like extreme acceleration, high vibration, wide temperature operative range, and so on. Our heritage is based on the peculiar optical and mechanical solution we implemented, and our military telescopes are becoming now an interesting option for the customer worldwide.
You gave me an Italian lesson with the word avogada, so I'm going to give you an English lesson, and the word is roundup. It's an old, it's a cowboy word where you put all things together in some kind of a grant or something like that. So the roundup I'm going to give you is I'm going to name you 3 topics, and I'm going to give you 30 seconds, and you got to punch through some creative ideas on what's going on with each one of these areas because you have a good perspective on them. The first one, give me 30 seconds on Earth observation, and what are the big developments in the next few years in that category?
Less than 30 seconds, John. First, a better volume versus performance ratio. The so-called SWAP, size, weight, and power optimization, it will be an important design driver for the future. Yes. Together with the capability to be operated from lower than usual orbit, closer to the Earth's surface for an improved imaging resolution.
Okay, your crystal ball for laser communications. What do you see in the future for that?
In this case, cost reduction and reliability are the main focuses now. Lasercom is working very well in laboratory, but is now important to make it market ready through an optimized process of industrialization. An amazing number of optical antennas will be deployed in the future. The hardware shall be inexpensive and, above all, really reliable and able to work under all weather conditions. Both are challenging items for a complex electro-optical device.
So, Gino, you can tell an American that we're going to put laser communications in work boots. That's the phrase that'll resonate with my audience. I don't know how to say work boots in Italian, but it's what we use here. And finally, number 3 of the roundup, space situational awareness. What developments is foresee in the next few years in that area?
Okay, easier here. In this field of application, the request is for a better resolution, basically. The owners of the SSA assets would like to know with a great accuracy what is happening up there. They want to know if an offender is getting close to their satellite in orbit, catching sensible information or hacking its control system, or be able to understand if a collision is on the way with a very small margin of error. To properly answer, a different range of optical systems with special adaptive optics are required to see more and better.
Well, we're coming to the end of our interview here, Gino. You have given us a great perspective on innovation. I'd like to thank our guest, Gino Bucciol, co-founder and chief development officer at Officina Stellare. Thanks, Gino.
Thanks for listening to Constellations, the podcast from Kratos. If you like this interview, please subscribe, tell a friend, and give us a review.